Tech revision with Mrs. Swanee Pooh.
Right, good morning Year 11 and Year 10 if you're listening as well. This is a video all about the different manufacturing processes that you need to know for polymers because polymers tend to be the focus that we have in the GCSE specification. So this is a page from the spec and you'll see it says that you need to know a range of different types of processes. One of them called wastage. Wastage is basically just cutting, removing things. Addition, which is adding things. So for example, if you're 3D printing, you are adding layers. If you are sewing, you are adding things together. And deforming and reforming covers things like where you're heating something up and you are molding it or shaping it, or making it a liquid and putting it into a mold and casting something. So the kinds of different questions that potentially could come up are things like this here. Okay, so name one specific commercial manufacturing process and describe, what it is used for. So you could, for example, talk about injection molding, vacuum forming, extrusion, lots of different things. We're going to cover those in today's video. So you may recognize this example of a resource I've given before, and you'll find this on the VLE, but you should be able to do a very short little description and a diagram of what all of these different processes are. So vacuum forming, drape forming, so these are the key ones that you need to know. So if you don't know any of these, it might be worthwhile going over them again, looking at some videos on YouTube. I'm going to put some videos on the VLE that show you each of these as well. But vacuum forming, drape forming, line bending, blow molding, injection molding, and extrusion. So what we're going to look at today is we're going to look at all of these different ones. The vacuum forming, drape forming, and line bending, these are all actually things that we can do in school, in our workshop at school. But these ones along the bottom, these are commercial processes, and large machinery is used to make these products in factories, and it tends to be that these factories are dedicated to making specifically this product. So the first one we're going to look at is vacuum forming. Straight away, there is a video on the VLE which you will be able to find if you look underneath this video on the VLE task. There is videos, if you just put into YouTube vacuum forming, you'll get lots of different videos that you can look at. But this is basically the sequence. Number one, a mold is made. Okay. The important thing about the mold is it's quite often made from something like MDF. You're going to have to bear with me a little bit with my writing. Something like MDF or styrofoam. That is terrible, but you get the idea. And also it has this thing called a draft angle. The edges of the mold are angled. Oh, I've even got it on there. There we go. They're angled because it means that the mold can be easily removed. So no undercuts, that's also important. So if you can't have the plastic go kind of like in within itself, otherwise you would not be able to remove the mold. So it needs to be a really simple hollow shape. So a mold is made, it's then placed into the vacuum former. And the bed of the vacuum former is called the platen, but I wouldn't worry too much if you don't remember that. Just call it the bed of the vacuum former. Number three, a thermoplastic sheet is placed above the mold. You know this because those are the plastics that can be easily heated and reshaped. It's usually the material called HIPS, so H-I-P, sorry about my terrible writing, P-S, there we go. HIPS tends to be the material that's used, and it's clamped securely over the top of the mold. Then the heater is turned on, which is here. So you have some heat that's heating up the plastic. That goes nice and soft. The plastic becomes really soft, and it goes over the top. So imagine almost like it would be all bendy like this over the top of the plastic. Then the mold is moved up, and the plastic would be bent up with the mold, and then the air is sucked out so that the plastic is sucked onto the mold to create the shape. This process is used for things like food packaging, yogurt pots, anything hollow. Also things like helmets and even bathtubs. If you have an acrylic or a plastic bathtub at home, it could be made using vacuum forming. This one is called drape forming. Again, I've put a little YouTube video on the VLE task for you to have a look at, but you can also just type that into YouTube if you wanted to. Drape forming is where you heat the plastic up and you just let it take the shape of a mold that you've created. So no vacuum forming, no pressure from above. You just let the plastic drape or fall over the mold that you've made. So this is really good for things like prosthetics, where it might be that you're making something like a one-off, because they might be slightly different or tailored or custom to each person. Also things like little one-off things like the windshield on this product here, that would be made using something called drape forming. Very simple process, but drape forming is just making a mold, heating the plastic up and letting it fall over the material. This one again is very, very simple. Line bending, we have a machine here called a strip heater, and this bit is basically a hot wire. So there's some heat coming off here. You put the material over the top and it allows you to create really easy kind of like right angles like this. So this is the kind of thing that you can do. You can basically bend acrylic up into different types of shapes. And it makes very simple products, but it's often used for things like display cases, point of sale displays. So you might see a clear acrylic stand with leaflets in it, and sometimes for shop fittings as well. So line bending is very simple. It heats the plastic along a line, meaning you can bend it up in kind of like geometric sort of shapes, almost like folding a net with card. Okay, so line bending. And these are now the ones that you need to have a really good awareness of. So things like injection molding, blow molding, and extrusion. These are the three key kind of commercial processes. And you'll see there is a similarity between all three. So every single one starts with this same part here. So from here, where I'm drawing this terribly dodgy line around, this part is the same on each one. Okay, and you can see that in each of these, it's exactly the same. Now that's a big advantage because it means you only need to remember that first bit, and the only bit that's different is the way that the mold is on the end of the injection molding. So let's talk through how these actually work, these processes. Again, there is a YouTube video that you can watch, but I'm going to talk you through it really, really quickly. The plastic pellets, which have been made through fractional distillation, are going into this thing, which is called a hopper. Okay, almost just like a funnel. They go into the kind of chamber here, the barrel, and this uses something called an Archimedes screw, which is here. And what happens is there is some heat here. So heat goes onto the side of the chamber. That melts the plastic, which is now here, melted. And what happens is then a plunger or a ram injects the plastic. So you can see that's been pushed forward and the plastic has now gone into the mold on the end. The part then cools and the mold usually opens up. So it normally splits in half and the plastic part ejects out. Okay, so that is injection molding. And it's used for a huge range of products. The computer that you might be watching this video on, the keys on there have been injection molded. If your phone has got any plastic parts on it, those will have been injection molded. Little plastic toys are injection molded. Anything that is relatively complex or is like a casing for something is usually been injection molded. So injection molding is a high volume process because it's quite expensive to start off. So the kind of startup cost is quite high. But once the molds are made, it makes the cost of each individual product really low because they can be made so quickly. So some of the key things, you might want to pause at this point and see if you can match the words at the bottom to the parts on the diagram. We're going to go through this now. So if you want to have a go yourself, just pause and we'll go through that now. So firstly, we've got the mold on the end. So this part, the mold. If you are talking about a particular product, try and make the mold look like the product you're talking about. It doesn't have to be accurate, but try and make it look like the mold that the actual product that you're trying to make. The Archimedes screw is this part here. An Archimedes screw is almost just like a spiral almost, and they were originally used to transport water out of the ground, but these screws kind of push things forward, which is why they're used in this area. We then have the plastic granules here, which are going into this thing, which is called a hopper, okay? And then you have the injection cylinder here, which is what is going to be injecting the plastic into the mold. So if you can do this kind of diagram with these words and a short explanation, you would get full marks for this process. And that's the heated chamber there. Right, the next one that you need to have an awareness of is blow molding. Now, blow molding is made for things like plastic bottles, anything that needs a watertight seal, and it's made ever so slightly differently. You can see that it's a kind of tube of plastic is blown in, and then air is used to actually inflate the plastic inside the mold. So rather than just being injected, loads of plastic being injected in, this actually kind of like almost like a sausage of plastic is injected. So you'll see that, just waiting for this diagram to reset itself. You can see the plastic goes in, and then this is almost like the sausage. Then the air gets pumped in and it pumps out the plastic to the edges of the mold, meaning the edges are nice and thin, and it creates that hollow casing inside. So that's blow molding. The main difference being that the mold is slightly different and it uses air to inflate the plastic inside the mold. And blow molding, again, I'll put another video on for you to have a look at, but this part is all exactly the same. This part is exactly the same as injection molding and exactly the same as blow molding. The main difference here, and I always use the example of a Play-Doh factory with this, is that you are extruding the plastic through a shape, and the shape would be the shape of whatever you want your plastic to come out. So if you wanted it to be a tube, it would be just like a circular shape. And what happens as the plastic is pushed through there, it comes out in a consistent kind of tube shape, whatever shape you wanted it to be. And actually what happens is there's water here, and that instantly cools the plastic to make it set and keep its shape. So this is used for things like tubing, pipes, and when we say plastic profiles, we mean basically different shapes of plastic. So it could be anything from square to, well, anything really. So extrusion is exactly the same setup as injection molding and blow molding, used for tubing and pipes, but you are pushing it through a shape that then basically the plastic is pushed through, and it keeps the exact same shape, and it just keeps going and going and going in a long tube or pipe. Okay, so what I would do after you've seen me talk these through really quickly, I would go back and I would watch the videos that I've put on the VLE for you on this task, just so you are happy with each of those different processes. Hope that was useful. I'll see you on the next video.